Hi, welcome everyone. In this today's video session, we are going to see how to write a Verilog program for 8 to 3 encoder. So there are two encoders we will see here without using any priority and also with priority. So this will be very useful for HDL Lab for electronics and communication engineering. So myself, Muhammad Ali, I am working as an assistant professor at Mysuru Royal Institute of Technology, Mandya. So as we are using this Xilinx ISC design suite to write the code, we'll open this Xilinx ISC design suite. So we'll see the tip and we'll close it by clicking on OK. We'll create a new project. We'll go to File, Create New Project. We'll give a name as encoder. So we look for the location where we are storing and click on next, next, finish. So we have created a project with the name encoder. Now we'll create a source file, click on project, new source. We'll select Verilog module and we'll give a name encoder and we'll click on next, next, finish. So here we'll write a program. First, we'll see how this encoder works and what does this encoder means. Here we are designing 8 to 3 encoder without priority. So here we have 8 inputs and 3 outputs. 8 inputs are taken as a name A underscore in and outputs are taken as Y underscore out. So here we have one more input that is called as enable input and this enable input is active low. So how this encoder works? So here if we are giving any input is high in the inputs out of 8 inputs, that will be correspondingly giving the encoded output in 3 bits. So we have 8-bit inputs, so we'll get the output as 3 bits, that is encoded value for any input. So let us take a values inputs A in. So we have 8 inputs, that is I have taken A in of 0, 1, 2, 3, 4, 5 up to 7. So this will get the A in as 8 bits, 0 to 7, 8 bits. So we have outputs, 3 bits output. So I have taken the name Y out. So in that Y out 0, Y out 1, Y out 2, these are the 3 output bits. So let us take if I have an input A in of 0 is high. So this will be encoded in the 3-bit format as 000. So for A in 1, which is high, so we'll get the output encoded form as 001. So for A in of 2 is high, so we'll get the output as 010. For A in of 3, if it is 1, we'll get the output 011. So like this, for A in of 7, if we have this input high, then we'll get this 1, 1 and 1 as a encoded output. So let us consider this enable input. So here enable represents we are enabling this module and we are getting some output. So if this enable bit is 0, that is active low, then only we'll get the outputs at the Y out. If this enable input is high, that is 1, so we won't get any output at Y0. So we'll get the high impedance. So this is shown in this truth table. So that is if the enable bit is high, so whatever will be the inputs. So here X represents as undefined. We can give 0, we can give 1, any value. So whatever we give, so we'll get the outputs as Z, Z, Z. That is all the 3 bits will be Z, which represents high impedance. So we'll write the code. So we'll take the names as output as Y underscore out. Inputs I have input I will take as a underscore in, comma, so one more input I need enable. So now we will declare the outputs and input ports. So the output y out is 3-bit output. So we'll take it as 2 down to 0. And it is y out. And the input we have is a in, and it is of 8 bits. So we'll take it as 7 down to 0. And we have one more input, that is enable. So here we are writing the code in behavioral abstraction level. That's why the output should be declared as register data type. So as in behavioral modeling, we need to take any of this initial block or always block. We'll take it as always block. Always at input a in and enable. For always, if we have any changes in these two values, we'll change the outputs. So if we have more than one statement, we'll start with begin and it will be ended with end. So in between that, we need to write multiple statements. First, we'll check for this enable input. If this enable is high, if this enable is high, we'll make y out is equal to 3-bit binary ZZZ value. Else, that is, we'll take a case statement. We'll take a case statement for A in. So if A in is having this value, the output will be this one. If it is 8-bit binary value 00000001, we'll get the output y out is equal to 3-bit binary 000. Like this, for 8-bit binary value 00000010, so we'll have y out is equal to 3-bit binary number 001. So this we can see in our truth table as we have discussed, that is for 00000001, that is A in is 0, we'll get the output 000. For this A in 110, that is 10, we'll get this 001. So for 100, we'll get 010. So like this, we'll write for all the values of inputs. So if we have other than these values, that is, we'll write a default value for that, that is default, and it will be y out is equal to, it will be 3-bit binary 000. So if we have any other values other than these, we'll get the output 000. Next, we'll end this case statement using this end case. Now this end is for to end this always block, and this end module is to end the module. So we'll save this and we'll check for syntax errors in this synthesize. We'll double click on check syntax. It will check for the errors if we have any. So here we don't have any errors. We'll move on to the next uh, step, that is we'll create a stimulus program. That will create a go to project and click on new source, and we'll create Verilog test fixture, and I will give a name encoder test. You can give any name, but it will be a top module for this encoder module. We'll give finish. It will create a new file with the name encoder test. So here by default, inputs will be in terms of registers and output will be in the terms of wires, nets. And we have instantiated this encoder with the name UUT. Now by default, it has given initial value as in as 0 and enable also 0. So as we have seen in our truth table, if enable is 1, we'll get the output as ZZZ. That's why we'll make it as enable 1 and input in as 8-bit binary value 00010000. So I'll make some values. And next I will give uh, delay of 10 time units. So here I will give some more values for this A input. Can make this 1 and this is as 0. Enable is also 1. So for these two values, we will get the output as ZZZ. Right. We'll check in this stimulus waveforms. So now we'll make this enable as 0 and we'll give some values, that is in the as per our truth table, that is 00000001. So I think I need to give this. Now I will take some more values. For all the values I will write this code. I have given these values for all the inputs. So now we'll save this and we'll check for the simulation. So click on simulation and click this encoder test and select here behavioral check syntax, and we'll check this if we have any errors or not. So there is no error. We'll click on this simulate behavioral module. So it will open iSIM simulator. They will check for this waveforms. So we'll select this all. So here we are getting some values for 000010. I'm getting the value ZZZ. At 0, if I have enabled 0, if I have enabled input 1, will get 0. So here I have made this enable as 1 for all the values. That's why I'm getting output as Z. So we'll change it to 0 such that we'll get the outputs. Once again, I will save this, check for syntax errors, and I will click on simulate behavioral module. So we'll get this error if we have not closed this previous simulation. So we'll close this and we'll once again right click and rerun this. It will open this waveform. So we can zoom it in and we'll see the waveform here. I'll zoom out a little bit. So here, so we have given enable as 1. That's why we are I am getting this output ZZZ. For different values also we are getting Z outputs. So at here enable is 0. So for input 00000001, I am getting output 000. For this 10, I am getting 001. For 100, I am getting 010. So 1000, I am getting this output as 11. So for this 100, 101, 110, and for last value I'm getting this output as 111. So like this we can verify this encoder. Now we'll see what is this encoder with priority. So we have seen this encoder without priority. Without priority, it says that if we have any one input is high, then only we'll get the outputs. Right. So if I have more than one inputs as high, so we need to check for this priority. So here let us consider I have one here. If I have one at input 2, I should get 0, 1, 0. What if I have one at here also? So for input 1, I have 1. So here we have given the highest priority in these two is for A in of 2. So that is for high LSB we have less priority. For the MSBs we have highest priority. So if I have 1 at this point and all the other bits are any other value, that is 0 or 1, so any value, if I have 1 at this A in of 7, then I will get this 111 as an output. So if I have the highest one is at A in of 5, so I will get this 101. So any of these values can be 0 or 1. So what we have seen in without priority, we are giving 0. So here for 5, I have A in of 5 is high and all the other values are 0. So if I have 1 here, so what will be the value? So I have written that it will be 0. For any other values other than this, it will be 0. So now in with priority encoder, so here we'll assign the priority, that is for 5. If the 5 input is high and if any other lower bits are high, then we'll get this 5 output itself, 101. That is, if we have the highest priority for this A in 7, if this A in 7 is high and all other values are any values, that is 0 or 1, we'll get the output as 111. So we'll write the code for this using this in the Xilinx. So we'll create a new project. So we'll give a name, priority, next, next, finish. So once we create this project with the name priority, we'll go to project, we'll click on new source, we'll create this Verilog module with the name priority underscore encoder ENC. We'll click on next and we'll finish it. So here we'll give the names as outputs as Y and inputs as A, and I won't take any enable because we know that how enable works. Now we'll declare the ports. Now as we know that we need to create output as a register reg. Now we'll take this always block and for always at input, that is A. Begin. So as we have not taken any enable, directly we'll write the output equations expressions. That is, we'll take the condition if A of 7 is high, then output Y is equal to 3-bit binary 111. So as we have seen in our truth table, so like that we are writing. Next condition is else if I have this A of 6 is high, then Y is equal to 3-bit binary 110. So like this, we'll write it for all the values. So for the last values, we'll take else y is equal to 3-bit binary xxx. So we'll end this always block by using this end keyword. So we'll save this file and we'll check for any errors in this synthesis, check syntax. So here we don't have any errors. So we'll go on, go to project, new source, and we'll click on this Verilog test fixture and we'll give a name as test. So for this priority encoder, we have given the simulation name test, and this is for priority underscore ENE. We'll finish. So this has created a test bench. So here, by default, values have been given. A value is 0. So we'll take any value. So we'll give the values as per our truth table. That is, if any of the value is high, so after that whatever will be the value. That is for a in of 2, if the value of a in of 2 is high and a in 1 is also high, a in 0 is also high, the highest bit is high is a in of 2. That's why we'll get the output 0 1 0. So we'll give some random values for this a values, that is a of 8-bit binary. In this, the highest bit is bit number 5. So then we'll get the 5 as a output 101. And also we have bit number 2 is also high, but we won't get this will be considered. So we'll get the output for this. So priority we have given for this highest priority. So we'll check for few values like this. We'll give some different values. So we'll save this and we'll click on this simulation. We'll click this test file, check for the behavioral check syntax, and now we'll click on the simulate behavioral. So it will open this iSIM simulator. Here we'll check for the output, click on this zoom to full view. So we can see here I have given 4 values. In this, the highest value output is at 5, that's why I am getting 101. So here in this bit number 0, 1, 2, 3, third bit, that is 0, 1, 1 I am getting. Here also I have given the value, highest values for fourth bit, 0, 1, 2, 3, third bit, bit number 3. So that's why I am getting 0, 1, 1. So in this highest bit we have given is for bit number 6, 0, 1, 2, 3, 4, 5, 6. Bit number 6 is high. So we have neglected this bit number 4 and bit number 2, and the highest priority is given for bit number 6. That's why we are getting the output as 110 as per our truth table. If bit number 6 is high, so whatever will be the value, so we'll get this value 1 1. This is how we'll verify these encoders using with priority and without priority. So we'll see the next programs in the next videos. Thank you.